So I want to just go through a little bit some important concepts around the median. You'll be familiar with how to find the median from Key Stage 3 and IGCSE. First thing you do is you've got a list of numbers. At its most basic level, you've got a list of numbers. You just arrange them in order and find the middle one. And when you first were introduced to the median, you were probably told to cross off the first and last and the second to last, and so on until you found the middle number. And that's fine for lists like this where you've got 11 numbers and it doesn't take very long to put them in order and just cross off like that. But when we get much bigger samples, that becomes quite time consuming. So it's very important that we are introduced to the concept of the n plus 1 over 2 value. All right, so in this case, you've got 11 numbers, so 11 plus 1 over 2 is 6, and we're looking for the sixth number, 1, 2, 3, 4, 5, 6. And when you've got an odd number of values, you get one value in the middle and it's really easy. But, and the textbook's not very good at, well, it doesn't sort of mention this at all. So what if you've got an extra value? What if I have 12 values and the 12th value is 20? Okay, well, now we have, instead of having 11 plus 1 over 2, we have 12 plus 1 over 2. And 12 plus 1 over 2 is the 6.5 value. So the 6.5 value, 1, 2, 3, 4, 5, 6, it's exactly halfway between the 10th and the 11th. Okay, so then in this case, the median is 10.5. Now let's change things again. What if, instead of this number being 11, what if this number was 12? And therefore you've got two 12s in the data set. Well, now, halfway between the 6th number and the 7th number, halfway between 10 and 12, then in this case the median would become 11. All right. Now, something else to note is that this extra number that I added, sorry, I'm just going to change this back to this number being 11 and this median being 10.5. Now, this extra number, it doesn't matter whether this extra number is 20 or 200 or 2 million. All right? The median wouldn't change. The median would still be 10.5. Whereas if this was the mean, if you were asked to calculate the mean of these numbers, the mean would be around about 1 million. So this is one reason why economists, for example, will use the median GDP per capita, in other words, the average income, rather than the mean. Okay, because if you've got a country with a very unequal distribution of wealth, the median is thought to give a better average than the mean. Even though the mean we often think of as the true average, the mean can be distorted by 1 or 2 or 5% of outliers. So if you've got a country where the vast majority of the population are working on really low wages in factories or farming in the fields, and then a small minority of the country are plutocrats or corrupt politicians and they're creaming off all the money at the top, then you might find that the median gives a better indication of average wealth than the mean. Let's look at this example. Okay, so first of all, I'm going to take out the owner of the factory, and we've got 8 15. We've got 15 people working in this factory. All right. So if we wanted to work out their median salary, 15 plus 1 over 2 gives me 8, and I'm looking for the 8th person. How do I find the 8th person? If I've got a grouped frequency table like this, I need to use the cumulative frequency. So 3, 8, 15. The 8th person, luckily, is just about in this category. So in this case, the median is 20,000. Now, what if, though, I now decide to include the owner of the factory? The owner of the factory pays himself 200,000 or herself 200,000 pounds per year. So this changes things somewhat. We're now looking for the 8.5 person. Okay, so again, using my cumulative frequency, I've got 3, 8, 15, 16, but the problem is that the 8.5 person is not anymore in this category. But you also can't say that the 8.5 person is in this category, because this category here is persons 9, 10, 11, 12, 13, and 14, and 15. So, if the 8th person earns 20,000 and the 9th person is in this category, and that 9th person earns 35,000. Well, we're looking for the 8.5 person, and the 8.5 person is exactly halfway between the 8th and the 9th. So their salary, even though this 8.5 person doesn't really exist, we're going to say that their salary is exactly halfway between 20,000 and 35,000. Okay, so the median in this case would be 20,000 plus 35,000 divided by 2. Okay, halfway between 20,000 and 35,000, which would give you 27,500. All right. Now, one thing there is therefore how to find the median from grouped frequency tables. The other thing, which is something that we'll come on to more and more, is the idea of which average is better. So if I put this data into my list and then found my one variable statistics, you'd find that the mean, what's happened with here? Okay. Okay, so I'm going to keep this in the video. The reason this has gone wrong is because I've set this up in the same way it is on the it appears on the table. And in list 1, I've got my frequency, and in list 2, I've got my variable. All right, so this is kind of the wrong way. So it's actually, I'm going to keep this in. So this is the reason this has gone wrong is because what this has done when it's calculated my variables, it's said that my mean is 2.185. Well, actually, because the reason it's done that is because it said there's 15,000 threes and 20,000 fives and 35,000 sevens and 200,000 ones. You don't need to redraw the whole table. Simply, in your settings, change your X list to be list number 2 and change your frequency list to be list number 1. All right. And now if I calculate my statistics, it gives me a much better reading. So you can see here a sort of a bit more of a real life kind of economics effect, that the mean, it's telling me the mean salary of factory workers is £36,875. So let's say £37,000. Whereas actually 15 out of 16 people earn less than £37,000. All right. So is that really a good measure of the average salary in this factory? Yeah, if the mean is telling me it's £37,000, well, 15 out of 16 earn less than that. Whereas the median is 27,500. Now, no one actually earns 27,500, but half the people earn less than it, and half the people earn a bit more than it. And actually, I would argue that 27,500 is a kind of more realistic salary expectation for most people in this factory than 37,000. Okay, so it's quite a nice real life example. Well, I made it up, but it's kind of, it works a little bit more like an economy than the median and the mean might work in real life if you're looking at economics, etc.